Okay, so talking about dilations, on the very beginning of your notes outline, you have 3 vocab words written on the notes outline. So a dilation is a transformation that enlarges or reduces a figure. So the best I can describe it that you guys deal with is if you open a document in PDF or a document in like Google Docs or something, and you want to hit zoom, like you hit zoom and go to 200 or zoom and go to 50. Does that make sense? So you're enlarging that by like 200% or you're reducing that by like 50%. And I know you guys do those things on the computer. So that would be creating a dilation. So then the center of dilation is a point of intersection of lines through each pair of corresponding vertices in the dilation. So a vertice is like a fancy way of saying a corner. So if you have a triangle, then like there are 3 vertices in a triangle, 3 different corners. Okay, and then the last one is a scale factor. That's a ratio used to reduce or enlarge similar figures. So a bigger scale factor, obviously the bigger the shape's going to get, smaller, the smaller it's going to get. So what we're going to look at first is we are going to decide whether or not each transformation is a dilation. And in order to do that, we're going to look at the ratios of the numbers. So, all right, so here I have 2 triangles. And on your paper, I know it's not in color. But up here, if you look, one's red, one's blue. So the red one is the original, and the blue one is the second triangle. So how you can distinguish that is if you look at your paper and you'll see A with an apostrophe and B with an apostrophe, C with an apostrophe, that stands for prime. So you would say that as like A prime, B prime, C prime, and that means the second shape, like the second, not the original. So when you're looking at your paper that's black and white, you look for that apostrophe. So what we're going to do is we are going to compare ratios of sides. So we're going to look at like side AB, and we're going to do AB over A prime B prime, and we're going to see what the ratio is. So side AB, if you count, is 3 units, and then we need to count the side AB prime. So it's 6. So then if I reduce that ratio, what's 3 over 6?
1/2.
1/2. Okay, so then we're going to look at the second side. So we're going to do BC over BC prime. So BC is 4 and BC prime is 8. And what does that reduce to? 1/2. So the ratios are the same. So that means that this is a dilation.
Where'd you get A?
From the blue.
From the blue triangle.
Where'd you get 4?
Right here. Right here on the red triangle.
Okay.
Okay, so now if we look at this rectangle, so we're going to do the same thing. So we're going to look at LP over LP prime. So you look and count your measurements. So LP, in this case, we're going from red to blue again. So LP is 6 over LP prime, which is 4. So 6 divided by 4. 1.5, or you could say 3/2 would be fine. Either one. And then LM over LM prime. So LM is what? 4 over LM prime right here is 2, and that equals what? 4 divided by 2 is 2. So those are not the same, right? So this is not a dilation. not a dilation. Okay, so we're gonna jump ahead to the next one. I'm going to have you guys come back and do this one. We're gonna do number 2 with the squares. So we're gonna do number 2 together, and then I'm gonna have you do number 1 on your own. So we're gonna look at LM over LM prime. So LM is what?
6.
That's prime.
Oh,
2. So 2 over 6, and 2 divided by 6 is 1/3. Okay, so then we're gonna look at MN over MN prime. So MN is 2 over 6 again. So that reduces to 1/3. So that tells us that this is a dilation because the ratios are the same. They're both 1/3. Okay, so I want you to do number 1. So you'll need to pause your video and do number 1. All right, so if I do BC, doesn't matter what order you do them in. Sorry, like BC or AC, it doesn't matter. Over BC prime, I would have 2 over 3. And then if I do AC over AC prime, I would have 3 over 6, which reduces to be 1/2. So those are not the same, because that 2/3 is 0.6 repeating and 1/2 is 0.5. So this is not a dilation.
Where did you get 6?
The 6 came from AC right here. You can also count your boxes if that helps, like count on the graph. Okay, so for this next part, what we're gonna do is we're actually going to use a scale factor and enlarge or reduce the image. So here we have a triangle, because we have 3 vertices, right? That's a triangle. And we are going to dilate the figure by a scale factor of 2.5. So that means we're gonna take every coordinate, x and y, and take it times 2.5. So A is 2, 2. So we're gonna figure out what A prime is. So take 2 times 2.5. 5. And then x and y happen to be the same thing, so they're both going to be 5. And then B prime, so 3 times 2.5. 7.5, and then 4 times 2.5. I heard 10. And then for C prime, 5 times 2.5. 12.5. And then 2 times 2.5 is 5. So, okay, now what we're going to do is we're not going to graph both of them every time but for the first one, we're going to do that. So we're going to graph the original and graph the prime. So I'm going to graph the original first, and you want to label with like ABC and ABC prime. And then you'll just have to do your best with your decimals and just graph it the best you can. Okay, so you're seeing that you're showing you increased it by a scale of 2.5. Your triangle got larger by 2.5. Okay, so we're gonna look at the next one. And the next one has a scale factor of 2/3. Okay, so 2/3 is not a terminating decimal, right? Like 1/2 is terminating, it's 0.5, but what is 2/3? 0.6 repeating. So whenever you have a scale factor that's a repeating decimal, you want to make sure instead of using the decimal version, you want to use the fraction button on your calculator and do 2 fraction, like 2 ABC3. Or look at your numbers and do mental math. So in this case, A, B, and C all happen to be multiples of 3. So finding 2/3 of it shouldn't be all that difficult to do mentally. Okay, so A prime. So 2/3 of 3 would be what? 2. 2/3 of 9 would be 6. So in this case, mental math is probably even faster than using that fraction button. 2/3 of 9 again is 6. 2/3 of 6 is 4. 2/3 of 6 again is 4. And we already did 3. Then you should get 2. Okay, so I'm not going to graph both of them this time. I'm just going to graph my prime. And then you always want to make sure you're labeling when you graph. Like I have my vertices labeled and I have the apostrophe there to show that it's my prime shape, which is the second shape. Okay, so I want you guys to take a look at the next one. So you're going to do this one on your own, and you're dilating by a scale factor of 2. So that means I'm going to take everything times 2. So you'll need to pause your video and do this problem. All right, so for this, your vertices should be A prime. All right, A prime should be 4, 4. B prime should be 6, 8. C prime should be 10, 4. And so for A prime, B prime, and C prime. So your triangle should look something like this. Okay. All right, the next one. They're not really numbered, but I believe you're on the back of the paper now. Back of your notes outline. So we're actually going to skip this one. You're going to come back and do this one. We're going to do this one together. So look at this problem. So we are going to dilate this by a scale factor of 1/3. So the scale factor is kind of small typed on your paper, but a scale factor of 1/3. So before we've always been given the coordinates. This time we are not. So what do you think we have to do? Find the coordinates from the graph. So A is what?
6 and 3.
So this is 0.
Oh wait, no, yeah, 6.
6 and -3. And then so A prime, we'll get to that in a minute. But B is what?
2 and -6.
You're close. 3 and -6. Okay, C. 12 and -10. 10. And then D is 9, -3. Okay, so then let's look at the prime coordinates. So we are doing a scale factor of 1/3. Most all of these are a multiple of 3, only one is not. So it should be easy to do. So 1/3 of 6
Two.
is 2. 1/3 of -3 is -1. 1/3 of 3, 1. 1/3 of -6, -2. 1/3 of 12,
Four.
4. And then 1/3 of -10. -3.3.
Repeating.
1/3 of 9, 3. And then 1/3 of -3 is -1. Okay, so on this graph right here, this is all in quadrant 1 where all the numbers are positive. And on my graph, not all of my numbers are positive. So what I'm gonna do is I'm gonna redraw my x-axis. So I'm gonna make this right here 0. And this right here is my origin. So that would be 0, 0. And then I'm gonna regraph. Does that make sense? So this would all be negative down here. Okay, so I want you guys to go back to the problem above that, and you're doing a triangle with a scale factor of 1/3. And then I have 2 more problems to add really quick to the bottom of this notes page that don't involve graphing. So go back to the top of the paper. So you're gonna go back to this problem, and I want you to dilate this triangle by a scale factor of 1/3. I'll give you about 30 more seconds. Okay, so for your scale factor of 1/3, you should have A prime is 1,3, B prime is 3,2, C prime is 2,1. And then you would graph that. Okay, so I'm gonna add 2 more to the bottom of this paper. So at the very bottom of your notes outline, you should be able to add 2 more. You don't necessarily have to write both of these down. If you could write the first one down, that would be helpful. And then we can just talk about the second one. So if you could copy the first one down. So what we're doing here is we are looking at just the coordinates and we are deciding what the scale factor is. So you're looking at what you would have to multiply the original coordinates by to get the scale factor of the prime coordinates. I'm seeing 3. So this is saying that A to get to A prime is all multiplied by 3. Okay, so this is a scale factor of 3. I agree with you. Okay, so the second one you don't necessarily have to write down, but I would pay attention to it. So on the second one, I don't really know off the top of my head what I have to take 2 times to get 1.5. Like quickly, I don't know. I'd have to think about it for a little bit. So a way that you can calculate this without, if you can't quickly see the mental math. So I want you to write this part down. The scale factor equals the prime divided by the original. So if you can't quickly figure out what the scale factor is, you can take prime divided by the original. So for example, you could take 3.75, which is this value, divided by the original x, and it would give you your scale factor. Okay, so 0.75. So the scale factor for this problem equals 0.75. So I would make sure you write that formula down. Prime divided by original. Okay, so for your homework, you're doing page 178, 179. You're going to get half of a sheet of graph paper. Here are the problems that you're graphing. You're graphing 7, 8, and 9, just in case you're confused about what you're supposed to graph.